Hey there everyone, welcome back to OneCodeCamp. This is Justin, and in today's video, we're diving into the basics of Java programming.
Exceptions are runtime errors that disrupt the normal flow of a program. For example, dividing a number by 0 or accessing an invalid array index will throw an exception. Exception handling ensures your program doesn't crash and can gracefully recover from such errors. A try-catch block is used to handle exceptions. Code that might throw an exception goes inside the try block, and the catch block handles the error. For example, under this try block here, let's create a variable named result. Value of this is 10 divided by 0. So this will throw an exception because you cannot divide an integer by 0. It is undefined. Let me add a comment here. This will throw an exception. Then here we will print the result. Again, this expression is invalid. So let's add some code here under the catch block. Let's say error cannot divide by 0. Maybe let's add some code here. This is supposed to be system.out. Program continues. Alright, so let me try to break this down. The try block here, as highlighted, contains the code that might throw an exception. For example, this one, you cannot divide by 0, so this will surely throw an exception. The catch block here specifies the exception type. As you can see, we have arithmetic exception here. This is the exception type that handles the error, and then this line will be printed. After handling the exception, the program continues executing the remaining code, as indicated here. So to test this, let's run our program. As you can see here, again, this statement threw an exception. Therefore, the code under the catch block is ran. Error cannot divide by 0. And after this try and catch block, the program continues. Now that we have discussed how to use the try and catch block, let's explore how we can handle multiple exceptions. A program might encounter different types of exceptions. You can handle them by using multiple catch blocks. So let me clear all of this first, and we will create a new example here. Let's say we will declare an array of numbers. Let's declare the elements 1, 2, and 3. And say we want to print an element inside our array. So this time, let's access the variable named numbers and pass the index here. Say we will pass index 5. As you know, we have only 3 elements, so the maximum index number should be 2. And here we're passing 5. This is an example of array index out of bounds. exception. So since this is a different exception type, we will change this arithmetic expression or arithmetic exception to this one, array index out of bounds exception. Let me just erase this one. Now that it matches the exception type, let's pass here our code. So we want to print error array index out of bounds. As I mentioned earlier, we want to handle multiple types of exceptions. So if we're not sure what the exception type is here, we can add multiple catch blocks. Let's say this one is for the arithmetic expression or arithmetic exception, I'm sorry. Now let's print our message. Error arithmetic exception. Occurred. And then let's add a finally block here. I will explain this later on. So execution finished. So once again, let me break down the code here. So here we have an exception under the try block, and then we can add multiple catch blocks to handle different types of exception. So in this case, we have an array index out of bounds, so this line will be executed. Now here, for the finally block, this finally block always executes whether an exception occurs or not, and is typically used for cleanup tasks. To test this out, let's run this program and see the output here. As you can see, since we have an array index out of bounds exception type, the line here was run or was executed, array index out of bounds, and then the code under the finally block is also executed. Execution finished. Now let's talk about throwing exceptions. You can use the throw keyword to explicitly create and throw an exception. For example, let me clear all of this first. To give you a demo of how this works, let's create another method here. Say this one is to validate the age, which accepts a parameter. And let's add the condition here. Later on, we will break this code down to explain this more. Say age is less than 18. We'll throw new legal argument exception. Age must be 18 or older. Otherwise, let's print age is valid. Alright, so in our main method, let's declare a try and catch block. And here, inside our try block, we will call our validate age method. And let's input 16, for example. So 16 is less than 18. So this code here will be executed. So let me add the semicolon here. And then for the catch block, we'll pass the exception here, which is the illegal argument exception. Then run the code here. See error. Get message. So we'll be able to get the message here. So the throw keyword here is used to create a new exception. So we are creating a new exception. We call this illegal argument exception. And then when the main program is run, when we call the validate age and add an argument of 16, since 16 is less than 18, this will be executed here. And then we have the illegal argument exception here. So this illegal argument exception is thrown if the age is less than 18. And then the try and catch block handles the exception and displays the error message here. So to execute this, let's hit run. And then as you can see in our output, we received the error. The message here was the message that we declared in our new exception here. The common exception types in Java includes arithmetic exception, errors like dividing by 0, array index out of bounds exception, accessing invalid array indexes. We also have the null pointer exception, for example, calling methods on null objects. And we have the illegal argument exception, which are the invalid arguments passed to a method. So I have a challenge for the viewers. Try creating a method that checks if a string is null or empty. If it is, throw an exception. Otherwise, print the string. So that's it for today's session on exception handling in Java. If you found this helpful, give it a thumbs up, subscribe to OneCodeCamp, and hit the bell icon so you don't miss the next lesson. Keep practicing, and I'll see you in the next video where we'll dive into object-oriented programming basics. Happy coding!